Hello, today I want to present the evolutionary AutoML named FEDOT and describe why we claim it as human competitive approach for automated design of composite pipelines. There are a lot of AutoML solutions exist, some of them based on relatively simple optimization techniques, some of quite complex. However, they cannot be claimed as human competitive. You can ask, why? The reason is the existing AutoMLs are mostly focused at a restricted structure of the pipelines. Some of them use linear pipeline structure. Some of them can produce the ensemble pipelines. However, all of them are quite limited by a set of predefined patterns, restricted set of building blocks. At the same time, the expert-based building of composite pipelines is different. The pipelines consist of different blocks, for example, neural networks, machine learning models, and we can describe the process of expert-based pipeline building as iterative. So it starts from initial assumptions and continue with the set of iterations that allow improving the pipelines and achieve the appropriate quality of solution for specific case. However, if we implement the human competitive AutoML, so we will have the factory of human competitive solutions in different fields. So our solutions named FEDOT, and it allows produce linear pipelines to avoid the overcomplications. Also, it allows produce the ensemble pipelines with different depths. And the most interesting one, it allows to generate the composite pipelines that can include different types of data, different types of tasks, different types of models. Of course, the problem is to automate the design of composite pipelines. We use the genetic programming technique to evolve the solutions. So we start from initial population, then we apply the crossover and mutation operators that allow us to modify the structure of directed acyclic graph, its nodes, edges, and hyperparameters of the nodes. The both single-objective and multi-objective formulation of the problem can be considered. This approach allows us to replicate the human logic of pipeline design and achieve the same result with same way. Also, we implement the structure sensitivity analysis technique that allow us to estimate the importance of each block, remove the redundant blocks, and also add the better blocks that existing one. Also, the importance for specific cluster of data also can be estimated for each block of the pipeline. Also, it's quite important to support the evolution from initial assumption, since the expert always start with existing knowledge to use it for model improving. And the FEDOT can modify the existing base pipeline, and also it can preserve it and add additional cascades of the model for the correction of the error and improving the final quality. So we have several human competitive results generated by FEDOT, and I will describe the most interesting results from this list. The first one is sea-surface level forecasting in the Arctic. We generated the pipeline that consists hydrodynamic model and data-driven model, and this solution allows us to achieve the better results than existing solutions for this case. Then the second case in flood forecasting hackathon, it was aimed to predict the river floods for Lena River located in Siberia, and we produced the pipeline that allow us to achieve the first place in this competition, and also we present the solution to the experts. They are hydrologists, and they were very impressed since the solution really overcome all existing solutions for this case. And the third case is oil chemistry prediction. We predict the quality of the oil according to its properties, and it's quite actual problem since the existing expert-based solutions are not allowed to achieve the appropriate quality. And so we generate the pipeline that allow us to overcome the existing solutions and also produce the human competitive result. So why our result is the best for this competition? First of all, it can produce the human competitive pipelines for large variety of cases using human-like logic. To improve this feature, we also implement the support for domain-specific objective functions that allow to resolve even very sophisticated tasks with human-like logic, since we use the objective functions that are specific for tasks that we want to solve. And finally, the sensitivity analysis allow us to estimate the importance of each node and explain the pipeline. Also, the FEDOT is quite flexible and extendable solution. For example, we use the same optimization techniques for machine learning pipelines and for Bayesian networks, and the results were quite interesting. Also, it's quite easy to use, so the users can resolve sophisticated tasks just with several lines of the code in Python. And finally, it's open source, so each user can use it, reproduce the experiments, modify, and achieve the human competitive results in different fields. Also, we have several preprints devoted to the FEDOT that describe different cases of its application. That's all. Thank you.